Okay, this first part of this problem is really difficult, and here's why. A compound containing the elements carbon, hydrogen, nitrogen, and oxygen is analyzed when a 1.2359 gram sample is burned in excess oxygen. 2.41 grams of CO2 is formed. The combustion analysis is also showed that the sample, that doesn't make sense. The combustion analysis also shows, this should probably say show, that the sample contained 0.04648 grams of hydrogen. Here's the interesting thing. They want you to take, given the mass of carbon dioxide, they tell you that the mass, the mass, the mass of the carbon dioxide is 2.241 grams. They want you to use that, go backwards to figure out what the mass of carbon would be. And believe it or not, this is the most difficult problem in the whole thing, and it's the first one. This is the best way I found to teach it. There's lots of ways to do it. But if you're going to make carbon dioxide from carbon and oxygen, carbon is C, oxygen is diatomic, carbon dioxide is this. And so the question is, if you have 2.241 grams of this, how much of this would you need to start with? And this is the simplest way to do this, is to think of this as a mass-mass stoichiometry problem. And so what happens is, remember, the most important concept in all of chemistry is the mole. So I'm going to add 12.01 plus 2 times 16. And when you do this, this is 14.01 grams per mole. And then this is 12.01 grams per mole. And I'm going to go up here and grab purple just for fun. And this is your U flow. Remember, you always start on the given and you end on the question mark. This is step 1. This is step 2. Step 3, we're going to use this 1-to-1 mole ratio. And then this is step 4. And so when we come down here, we have 2.241 grams of carbon dioxide. If it bugs you that there's nothing here, put a 1. There's 40, and check, first set of parentheses is done, 44.01 grams of CO2 in 1 mole of CO2. The reason why the mole is the most important concept in all of chemistry is you can't use a mole ratio unless you're in moles. And to get 1 mole of carbon dioxide, you need 1 mole of carbon. And then we know, check, and then we know that 1 mole of carbon is 12.01 grams. And this would get us into grams of carbon. This has 4, this has 4, this has 4. The rest of these as counting numbers. If you put this in your calculator, you will get 0.6116 grams of carbon, which is the answer for AI. All right, next thing. When the compound is analyzed for nitrogen content only, it's 28.84%. So this stuff is 24.84% nitrogen. Well, remember when you do percents, percent means per 100. And so whenever you do a percent, you have to convert it to decimals. And so 28.84% of the whole sample is nitrogen. So if I take 28.84% of 0.2359 grams, we will get that this stuff has 0. Let me grab the eraser, sorry about that. This is 0.3564 grams of nitrogen. Next question, determine the mass of oxygen. Well, here's the thing. This is carbon plus hydrogen plus nitrogen plus oxygen equals 2.359 grams. In I, we found out that this was 0.6116 grams. In II, we found out that this was 0.3564 grams. In the original problem, they told us that this was 0.0648 grams. And then that plus, and we don't know oxygen, that's X, and that is 1.2359 grams. And so we get X plus, what would this be? I think it is 1.0328 grams. When I add, let me just check this quick on my calculator, 0.6116 plus 0.0648 plus 0.3564, it's 1.0328 equals 1.2359 grams, and then to subtract the 1.0328 grams from both sides, you end up with X is 0.2031 grams of oxygen. Yep. All right, so now we know the mass of all of them, and now here's the question. This is a very long question. What's the empirical formula? Remember, we have 0.6116 grams of carbon, and we know that there are 12.01 grams of carbon in 1 mole of carbon, and these both have 4 sig figs, and when I do that, I get 0.0, that doesn't count, it's not a final zero, it's not a sandwich zero, so 0.05092 moles of carbon. And then we have 0.0648 grams of hydrogen, and we know that 1 mole of hydrogen is 1.008 grams of hydrogen, and so this ends up being 0.06429. But actually, this has 3, so I probably should make this a 3 moles of hydrogen. And then we have 0.3564 grams of nitrogen. And I know that 1 mole of nitrogen is 14.01 grams. And when I do that, that has 4, that has 4, I get 0.02544 moles of nitrogen. And then finally, oxygen is 0.2031 grams of oxygen. And I know that there's 16 grams in 1 mole of oxygen. And when I do that, I end up with 0.01269 moles of oxygen. And so if I do my SLF, my stupid looking formula, I get carbon 0.05092, hydrogen 0.06429, nitrogen 0.02544, and oxygen 0.01269. And remember that we divide through by the smallest number of moles. And if you do that, you end up with C4H5N2O. That's a tough problem, especially the first one. Okay, a different compound. This is a totally new problem. A different compound is an empirical formula of C1H2Br, has a vapor density of this. Find the molar mass. Here's my favorite equation. Molar mass equals Mr. T conquers over pervs. Hopefully I've derived that already. But remember, density is mass over volume. So you can also write Dr. T conquers over pimples if you want to think of a dermatologist, because mass divided by volume is density. And so we have 6.00 grams per liter. That's the density. R is a constant. It's 0.08206. Not back in 2006 when this problem was written, but that's the new value on the sheet. They used to use 0.0821 atmospheres times liters over mole times K. And then that's R. And then the temperature is 375 K. And then the pressure is 1 over 0.983 atmospheres. And the beauty of this problem is atmospheres cancels with atmospheres, and K cancels with K, and liters cancels with liters. And we have grams on the top and moles on the bottom, which is awesome because we're solving for molar mass. And this has 3 sig figs, this has 4, this has 3, this has 3. It's a 9, by the way. It's this guy right here. And we end up with 100. If you put that in the calculator, 188 grams per mole. And again, the empirical formula, which is the simplest whole number ratio, times some constant x equals the molecular formula, which is the real formula of the molecule. And so when you're doing this problem, x is always going to be the molar mass of the molecule divided by the molar mass of the empirical formula. And so an interesting thing happens here in that in I, we just solved for this was 188 grams per mole. And then they told you the empirical formula was CH2Br. So if you go 12.01 plus 2 times 1.008 plus 79.90, and you add those together, you end up with 93.93, because when you add, you count decimal places, grams per mole, but because formulas always have to have whole numbers, this is approximately 94 grams per mole. And how many times does 94 go into 188? Twice. And then so what happens is, I'm going to hit extend page, we end up with the empirical formula, which is CH2Br, but we have to double it to get the real formula. And so the real formula is C2H4Br2.